2027 BMW 3 Series. The digital world may seem invisible, but the technology behind it has a very real physical footprint. Every website, video, file, and AI system depends on computers, networking equipment, storage, and data centers. All of this requires electricity. As cloud computing, artificial intelligence, streaming, and connected devices grow, so does the energy required to operate digital infrastructure. This has increased interest in green data centers and sustainable computing. The goal isn't to stop using technology, but to make it more efficient while reducing its environmental impact. What is a green data center? A green data center is designed to operate with greater energy efficiency and environmental sustainability. Traditional data centers contain thousands of computers running continuously and require substantial cooling. Green facilities reduce their impact through efficient hardware, improved cooling, renewable energy, smarter management, and better building design. Even small efficiency improvements can make a major difference when applied around the clock. Why data centers use so much energy? Servers are the biggest electricity consumers, but data centers also require power for cooling systems, networking equipment, storage, lighting, security, backup, power pumps. Renewable energy is one of the most important ways to reduce a data center's environmental impact. Solar, wind, hydroelectric, and other renewable sources can reduce dependence on fossil fuels. Some technology companies purchase renewable energy, while others locate facilities in areas with abundant clean electricity. A data center powered primarily by hydroelectricity, for example, can have a much lower carbon footprint than one relying heavily on fossil fuels. More efficient hardware, modern processors can perform far more calculations using less electricity than older hardware. Replacing outdated servers can therefore improve efficiency, although manufacturing new equipment also requires raw materials, transportation, and energy. Sustainability is often about balancing efficient modern hardware with keeping existing equipment useful for as long as practical. Smarter cooling technology is changing rapidly. Traditional facilities rely heavily on air conditioning, while newer data centers increasingly use advanced airflow management and liquid cooling. Liquid cooling is particularly useful for AI systems because powerful AI processors generate tremendous amounts of heat. Removing that heat with liquid can be more efficient than relying entirely on air. Using outside air, some data centers can use naturally cool outdoor air instead of relying entirely on mechanical refrigeration. This approach, often called free cooling or economization, can significantly reduce energy consumption in suitable climates. Location is therefore an important consideration when building a data center. Reducing water consumption. Water is another environmental concern. Some cooling systems consume substantial amounts of water, which can be problematic in areas experiencing drought or water shortages. Operators are increasingly exploring closed-loop cooling systems and other technologies that reduce dependence on fresh water. Artificial intelligence creates new challenges. AI is making sustainability more complicated. Training and operating advanced AI models requires enormous computing resources. Large AI systems can involve thousands of specialized processors, creating additional demand for electricity, cooling, networking, and data center capacity. However, AI could also help solve some of these problems by optimizing cooling, predicting equipment failures, balancing workloads, and reducing wasted computing resources. AI is therefore both part of the energy challenge and potentially part of the solution. Making software more efficient. Sustainable computing isn't just about hardware. Poorly designed software can consume unnecessary processor power, memory, storage, and network bandwidth. Developers can reduce energy use by optimizing code, minimizing unnecessary processing, and reducing data transfers. A small improvement becomes significant when software runs on millions of devices. Extending hardware lifespans, keeping computers and servers in service longer, can reduce the environmental impact of manufacturing replacements. Businesses can also refurbish or repurpose older equipment for less demanding tasks. When hardware finally reaches the end of its useful life, responsible recycling can recover valuable materials. Sustainable cloud computing can improve efficiency because large providers can consolidate workloads and keep hardware more highly utilized than many small private server environments. However, cloud computing isn't automatically green. Its environmental impact depends on the data center's efficiency, electricity source, hardware, and how efficiently customers use their resources. Reducing digital waste. There's another form of sustainability. Reducing unnecessary data. Businesses often store huge amounts of outdated files, duplicate information, old backups, and unused accounts indefinitely. All of this requires storage capacity and electricity. Deleting unnecessary information, improving data management policies, and avoiding needless backups can reduce storage requirements. The future of sustainable computing. Green data centers and sustainable computing will become increasingly important as digital services and AI continue expanding. The future will likely involve a combination of renewable energy, efficient processors, advanced cooling, smarter software, better data management, and longer hardware lifespans. Technology isn't going away, and neither is the demand for computing power. The challenge is making the digital world more efficient so that its environmental footprint doesn't grow as quickly as its capabilities.